Hello everyone, welcome back to my YouTube channel. Today we are going to see State Board Class 10 Science 1 Chapter number 7 Lenses. In that today we are heading towards second part for this particular chapter. In the first part already we have discussed about the spherical lenses. In that we said about the different types of the lenses, that is a biconvex, planoconvex, positive meniscus, bioconcave, planoconcave, negative meniscus, and then after that we studied about the various terms related with the lenses, that is the center of curvature denoted by letter C, radius of curvature by the letter R, optical center O, principal focus F, then the focal length, then the method of drawing the ray diagrams, the three different rules related with the ray diagrams, then afterward the how to draw the ray diagram, that also we have discussed. And this is a table which is on your screen. This particular table is showing the position of the object, position of the image, and then how the image is getting formed, and then the size of the image, what will be the size of the image in the different cases, and then at the end the nature of the image. This particular table, the 6 ray diagrams they have given, which you are supposed to draw and send me in the PDF format in the Google Classroom. So this is your activity. Further is what we are going to see today is images formed by concave lenses, because still here we had studied about the image formation by the convex lens. So when we talk about the convex lens, which is also called as the diverging lens, and why it is called as the diverging lens, that already we have discussed in the previous video, that when the light rays are falling on the concave lens, then it's going away from the principal axis, it's moving away from the principal axis. Then due to that, the light rays which are after refraction through the lens, they are moving away from each other, and that's why the concave lens is also known as the diverging lens. Further, when we talk about this particular lens system, then you can see here the ray diagram they have shown. Here the position of the object is here. One ray which we are supposed to take through the paddle to the principal axis, that will move away from the principal axis in such a way that the backward direction it will pass through the focus, and the one ray which is passing through the optical center will go undeviated, and this is the position of the image where these two rays are intersecting. But this will be a virtual image. Why virtual image? Because here this portion of the light ray is a virtual, it's not the real. Why? Because light never travels in a backward direction. So this we are taking it in a backward direction, so it is a virtual part, it's imaginary. So due to that, this image what is getting formed over here will be a virtual image. Further, when we talk about this particular section, the concave, that is the position of the object image, like the convex table what we are having, the ray diagram for the convex lens, for that the table we have seen same way here also. So this is also your one of the activity which you have to complete and send me back in the form of a PDF. So further is next what we have to study is about the sign convention. This sign convention is actually exactly same way what the sign convention we have studied in last year's science, where we studied about the sign convention for the mirrors, spherical mirrors. If you remember, there we studied where we have the pole of the mirror that we consider as the center or the origin for the axis which we are using for the lenses. So here also, if you want to see, then this is like axis, your coordinate axis, x-axis, y-axis. Here we have positive numbers 1, 2, 3 like this. Here -1, -2, -3 like that. We have the numbers. So actually we have here the positive side. This side we have negative, and above the principal axis positive and below the principal axis is negative. So this is a sign convention which we are using for the lenses also, which is exactly same as what we used for the spherical mirrors. The next what we have to study is a lens formula. Mirror formula already we have studied. If I want to write down the mirror formula is 1 upon V plus 1 upon U, and that is equal to 1 upon F. So you can see the difference between the lens formula and the mirror formula is just this. Here we have negative, this is negative, and this one is positive. Otherwise, the terms, the way of writing, everything is exactly same we have. There is no difference in the terms. Only the difference is one sign. Lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. Whereas in a mirror formula, we had 1 upon V plus 1 upon U is equal to 1 upon F. And the terms, that is V, U and F, they have their names. V is the distance of the image, U is the distance of the object, and F is the focal length of the lens. And this particular formula we are using to solve the various numericals or to calculate and get the result theoretically where the image will form for the particular lens if we know the distance of object kept from the lens and its focal length. Further, the next word we have to study is a magnification. Magnification is nothing but what? The ratio of the height of the image to the height of the object. Means basically it is nothing but the finding out what will be the extent of magnification by the particular lens. And for that we are using a formula, magnification, that is M is equal to height of the image upon height of the object. So M is equal to H2 upon H1, and the same way we have a formula for the magnification in the terms of distances also. So that is V upon U. Further, the next what we have to study is the power of lens. Power of lens is nothing but how better way the particular lens can magnify the things. So here the capacity of a lens, you can see the capacity of a lens to converge or diverge incident ray is called its power. The power of the lens depends on its focal length, and the formula to calculate it is P is equal to 1 upon F. But the care what we have to take, the focal length should be in meters, not centimeter. If you want to calculate the power of the lens, the focal length should be in meters. Very important part while solving the numericals. You should take care of this, that focal length for the lens should be in meters. The inverse of focal length will give you the power of the lens, and the unit to measure it is the diopter. Diopter is a unit for the power of lens. And next is combination of lenses. If two lenses with focal length f1 and f2 are kept in contact with each other, the combination has an effective focal length given by this particular formula, that is 1 upon f is equal to 1 upon f1 plus 1 upon f2, where f1 and f2 are the focal lengths of the particular lenses, and this f is nothing but the focal length of the combined effect, or the focal length for the combined combination of the lenses. And power, that is P is equal to P1 plus P2, means power directly we can add, but for the focal length we have to take the inverse of the focal length. Next, they have given a numericals, which we will see at the end of the chapter. Once when we are finishing with all this particular theory part, we will go towards the numericals, and that also we will discuss in the form of videos. Now, in the next lecture, we will discuss about the human eye, its working, its structure, and the defects related with the human eye and how we can correct with the help of the lenses. So this all we will see in the upcoming video, and for this particular video, for this particular session, you have the work to complete the ray diagrams for the convex and the concave, and that you have to post back to me in the form of PDF.